Start recording. Functions. All right. I actually recorded this video twice. I will remove this. I actually recorded this video twice last night, and the sound was off when I checked the recording. And today I recorded with an output in 2K, but it was kind of lagging. The sound was fine, but it was lagging, and I went all the way to the end of the Nix language tutorial. So it took me like hour and 50 minutes now to get from functions to end. So now I have to do it again. I have to do it again. Yeah, let's do it again. So, you can run through this really fast, right? You can do it. Or you can just slowly sip, and try things out, and write things out and type things out, right? Great, great. Um, all right, so functions are everywhere in the Nix language and deserve particular attention. A function always takes exactly one argument. Argument and function body are separated by a colon. Wherever you find a colon in Nix language code, on its left is the function argument or the parameter. On its right side is the function body. Or so on the left side, we defined the inputs to our function, and on the right side, we define what we're going to do with those inputs. Same as xx, right? We have a lambda x, we give it a 2, so the 2 comes in, so the 2 comes here, and then we lose the head, and then we get a 2. So same thing is with x is x plus 1. That's kind of an increment lambda function. So we give it a 2, we're going to get a 3. The 2 gets inside of the x, the head removes. 2 plus 1 is 3. So that's the first basic functionality. The next functionality, the next way to make some kind of a scope, so to encapsulate it within a space. Now it's also within a space, but it's anonymous and it's general. We have to call it each time. So we cannot just call it like with a name, like with an inc, undefined variable inc, except if we give it a name. But we can give it a name like this. Let inc be what? X and x plus 1, and that will be this in what? In not x, but in inc, right? So let increment is x plus 1 in inc. And now we have a lambda. It's anonymous let expression. So can we call it? No, we cannot call it, but we can apply it. Let inc is x plus 1. So in inc, and we can apply it to what? To a number. Let's do 5. So we're going to get a 6. So we could name this now an inc, right? Increment. Our increment function is going to be a let inc equals x plus 1 in inc. Now we can use this now. We can use this now, right? So we can do increment. Increment 1 is 2. Increment 2 is 3. But we can be also functional in the sense increment 1, right? So what are we going to do? Increment 1 is 2, and increment 2 is 1. So increment 2 is 3, right? So we get a 3. So that's same as increment 1 is same as increment 2. So that's how actually you define numbers, right? Like, look at this. 1 is increment 0. What's a 0? 0 is 0. Let's do this. 0 is 0. or like increment -1. No, then we so 0 is increment +1. No, okay, 0 is 0. 1 is increment 0, right? What's 1? 1 is 1, you see. 2 is increment 0. I think this is called, I forgot, in math, like the way you define numbers, the way you make numbers, the inductive method. This is the inductive method. So 2 is going to be 2, right? And then let's do 3. 3 is going to increment 0, right? And then we're gonna get 3. But now we can use these things. We name them. We do have 1. We do have 2. We do have 3. So we could do 1 plus 2, and that's 3. We could do 2 plus 2. That's 4. We could do 3 times 2. That's 6. Or we can do 3 times 3 times 3 times 3 times 2, right? And we get 54. So this is how we just defined, our numbers, right? So what it's saying here is a single argument. So, okay, when you have a single argument, x plus 1, so that's the x plus 1. So the argument is x. That's the argument. It has only one argument. And you can see it because it will take only one argument, right? We can give it a 2, we get a 3. If we give it 2 arguments, like 2 and 3, it will be an error. Attempt to call something which is not a function but a integer. Yeah, I don't know, but we gave it too many arguments, which is not a function but an integer. Oh yeah, x apply to this. Maybe because it's looking at space, at white space as function application. Yes, because it takes one argument. So this is applied to this, and this is applied to this, and this is called something which is not a function but an integer. Probably it relates to 2. This is not so clear, but it is clear, yeah. But you see, if we give it, that's one argument, right? One parameter. If we have a function with plus y, that's the add function. Like the add function takes 2 numbers and it adds them. Or yeah, but it takes 2 arguments or parameters, and let's 2 and 3. So now we can give it 2 and 3 and it will output 5. So that's here, multiple arguments via nesting, x, y, and x plus y. Attribute set arguments. Now we're kind of doing the same thing, but with attribute sets, which are the basic data structure in Nix, right? So we have an A and B, and this is an attribute set that has an A and B, and then we have, so A and B, and A plus B, right? So that's a lambda string. And what are we going to do with it? With default attributes, A, B, this is just showing that the B is like in a B, it's all like in the definition itself, B is defined as a constant with a default value of 0. And then A plus B, and then later here you're going to write, I don't know, A is 5. And then it's going to just add it to this default value. A plus B is A is 5 plus B, the default value. With additional attributes allowed, A, B, the ellipsis, that means it can take more attributes, but it's still going to do just A plus B. It's going to ignore the additional attributes. Named attribute set argument, args at AB, the ellipsis, A plus B plus args C. When you have this args, then you can actually add some extra attributes that are not declared in the first definition, right? In declaration, you did not declare a C, but you did write args at. And then if you want a C or any other thing, you just have to write argc, and then the calculation is going to work. Otherwise, if you just add C and you did not declare C, A plus B plus C will not work. Or AB, so this just says args can be here or args can be at the end or at the beginning of the definition. Functions have no names. We say they are anonymous and call such a function a lambda. So lambda function is an anonymous function. That's what we said. Anonymous in the sense you cannot call it, right? Even this, it's a lambda function. You have to write it again, right? I'm calling it, right? But I have to write the whole definition again. When I say call it by name, I cannot call it by name, only if I give it an id, let's say a name, and now I can call it. It's not anonymous anymore. I can do id 2, I get a 2, right? I don't have to call it. I gave it a name, so it's not anonymous anymore. I think that's correct, yeah. So x plus 1, a lambda. So right, this is an increment. The lambda indicates the resulting value is an anonymous function. As with any other value, functions can be assigned to a name. Example, let f is x. This is an increment in f, and that's a lambda. And then later you can apply it, right? Calling. Well, maybe this is the wrong. I said to call a function because I gave it a name. I think it might not be correct. You call a function when you apply it to something. So I called it when I, no, this is not correct. I named it. This is a question if it's still an anonymous one. Maybe it's not an anonymous, it has a name, but I didn't call it. Yeah, that was wrong. The definition I said. So I gave it a name, so it's not anonymous anymore. But when I give the function an argument, such as a 2, then I'm calling it. So you call a function by giving it an argument. You cannot just call it id. If I just say id, you just get a lambda, right? But you call it by giving it something, and it gives you back something, right? It's like communication. Id 4 gives you 4. And here we have an increment. So let inc equals x plus 1 in inc, right? So we have a lambda, right? It's written lambda. But if we want to call the function, all right, we want to call it. We cannot just, you cannot write inc now because let, it's outside of the let scope. So let's do it again. Let's inc equals x plus 1 in inc, and now we're going to call it with 5, and we're going to get a 6. So you see, let's erase this. So we're going to get a 6. Now we called it. Calling or applying. I guess applying. Yes, also known as function application. Depends what you like. I like more to apply. Eval apply. That's the whole Lisp thing. Eval apply with the magician. But that's kind of cute. That's really nice. Sitsp, yeah, eval apply. Maybe we could do like structure and interpretation of computer programs in Nix. That would be nice. Where is the wizard? There's the wizard. There's the wizard. Eval apply. Wait, this is the famous music. You really, guys and girls and everything. Yeah. Yeah, I'm saying guys because when I was in New York, they would just use guys for everything. I'm not sure how correct is this these days. This eval apply. This is legendary. Oh my god, this is so magical. I used to watch this and I was so in awe. Oh my. This is beautiful. I don't know how this is known, yes, but this is just so beautiful. Science and interpretation of I should watch this again. I used to watch this SITSP lectures, and I kind of miss that now. Do you have the yes? Look at this. Look at this overview introduction. Look at the first music. Wait, we have to check this. All right. And look at this, it starts like computer science, right? He says it's a course about computer science, and then it's a terrible way to start. It's not a science. Might be engineering or art. Magic. All right. Gosh, I missed this. Not about computers. All right. Oh my. I'm getting so soft now watching this. You should really watch at least the first lecture. The first lecture even just, and the second. Overview and introduction to Lisp, higher order procedures, compound data. This is procedures and processes, substitution model. This would be fun to do, like Simon state inside it. Maybe I would understand this now much better than like 5 or 6 years ago when I watched this. I used to watch this, but there's been already 6 years I haven't been watching this. This is so beautiful. This is so beautiful. Yeah, I'm like really inspired by this. All right. All right, calling functions. Right, calling functions with an argument means writing the argument after the function. We did this, right? Example. Now comes a little tricky, simple, but it might look tricky. Now we're gonna provide, here's like the let f blah blah, right? Let f x, this is the increment function in f1. So we're providing the 1 and the x goes out and 1 plus 1 is 2. But now we're gonna do let f, right, x and xa. So it's like, wait a second, what's going on? Am I yelling? Is this sound all right? It's all right. So now this is already a little bit more intricate, a little bit more subtle. Let f is x and then xa. So a, this is like a set. It expects to get a set, not a number. A number is going to be inside of a attribute set. So this is now getting already a little bit more subtle. So let f. So if I have select Nix Dude, I don't have anything here. Dev. Oh, Nix Dude. Let's just remove this because let's just rf. I think R is enough, right? Yeah, I don't have to do RF. Let's do this. Let R, let's just call it an example one. Example one.nix. Just going to do example one.nix. So we have a let and in, right? And we have a increment function. No, we do not have an increment function. We are accessing a value within a attribute set. So the set is going to be the x, right? Where it's going to take its place. And we're going to access the a value. That's it. That is it's going to do. And now we have to write, like, what's the value? Like the f is, no, we don't have to write an equal sign. What's the f? Well, the f is, it's funny, it's not like x. You don't write why not what's x? F is this set, accessing the set. And f is where f is a1, right? And that's it, right? So if we now Nix instantiate, if we Nix instantiate this eval example1, we're going to get a 1. It accessed the attribute set and it accessed the value 1. So if we just gave it, and you see, if we just wrote 1, it just wouldn't work, right? It wouldn't work. You see, while selecting an error, you see, while selecting an attribute, this wouldn't work. This wouldn't work. So let's do a little more complex example. The above example calls f on a literal attribute set. Literal attribute set. What's the meaning of literal attribute set? What's the meaning of literal? What is meant by literal attribute set? What is the meaning of literal? Yeah, I mean, I understand when something is literal, but literal is used to describe taking at most attribute set. No, wait. Literal gains a specific meaning expressed directly. Yeah, it doesn't. This is just defined explicitly. Maybe because it's defined explicitly. Name example package. A literal attribute set. So what would be a non-literal attribute set? What would be a non-literal attribute set that is not statically defined in an entirety at the point of declaration? All right. It may be constructed dynamically, modified by functions. Dynamic construction. Let dynamic built-ins read file version text reads file from a file in name dynamic package. All right, the version attribute. Dynamic is not literal because it depends on the contents of a file that it's read. Version overriding. All right. Inherit base package name. Oh, this is interesting. All right. So that means the literal, but we define the above example calls f on a literal attribute set, which is a1. One can also pass arguments by name. Okay, we can name them. Here, f and okay, we can name a1. We can put it inside of the let. So okay, this won't work, right? But we can do v is, and we can do it now. A is 1. Now we have to do this, and then we do v. So right, if we do this, and we're going to get 1 again. So now we kind of took this a1 and we named it. So now we have f and b. We could do c. Maybe we could do like f is xa. So yeah, we can access anything. We can access v is xa plus. Well, let's try something. All right, let's try something. Can we do xy xa plus yb? Can we do this? xa plus yb. And we're gonna do a is 1, a is hello, and b is world. B is world. So would this work actually? Lambda. All right. Lambda. If we do strict, lambda why it won't example one, hello world. Can it like output it in FV? F, it's accessing it. How to extract the hello? FV, right? How to extract strict expression arg? There's probably some kind of an attribute way to extract, maybe because of the characters. I don't know. Let's move on. Since function and argument are separated by white space, sometimes parentheses are required to achieve the desired result. Oh, parentheses. Wait a second. Maybe what would happen if we do like this as lambda? Nope. What if we put it inside of a list? Lambda inside, it won't evaluate it. Yeah, that's interesting. Since function and argument are separated by white space, sometimes parentheses are required to achieve the desired result. Am I recording? I'm recording. All right. Example x plus 1, 1. Okay, this is again the increment, detailed explanation. Will we read it? Expression applies the anonymous function to the argument 1. The function has to be written in parentheses to distinguish it from the argument. Yes, otherwise it wouldn't be clear, right? Yeah. X plus 1, 1. I guess would be, I guess 1 would, because of the white space, it would try to apply 1 to 1, which wouldn't make no sense, which makes no sense. So that's why, because white space denotes function calling or function application, just like in Haskell, which is cool. Example list, like space denotes connectedness. Kind of true. Example list elements are also separated by white space, therefore the following are different. List elements are also separated by white space, therefore the following are different. Oh, list elements are separated by white space. Oh, that's why it's not applying here, FA. But it's a lambda, and then this is a y. Okay, let FA. This is different. This is kind of like this, but X, we are accessing here, right? XV, A, VA, and VB. VA. Wait, I just have an idea with this. F, VA, and VB. Would this work even? No. No, while selecting an attribute. Yeah. List elements are also separated by white space. F, so this is again the increment. A1. So in FA, okay, we just calling this function with an argument A. But we don't just provide it here like before that we did with let. When we did let this and then in F, I don't know, 5 or 6, but we declare the argument that we are providing, we declare it here along the F. So you could do the same thing with X and Y. Like you could do hx example 2.nix. Let's say you do let's say you do add is, we're going to do an add. Okay, x, y, x plus y, and you do x is 3 and y is 5. I think yeah, I have to. Yeah, I can do it, you see. So add is this, and as now what? Now we're gonna do what? In what? In FA, we have to apply it. What do? Add x and y. Oh yeah, we just write add x, y. So we can do add x, y. Would that work? sh nix instantiate eval x2. It's 8. It works. Add x, y. So yeah, x, y, x plus y, x is 3, y is 5. Okay, let fx, this is an increment. We're putting it in a brackets. And but when it's interesting when you put it, it's like when you put it in a list. When you put it in a list, it's like it won't apply it. Look at this. This is interesting. It says there's a function, and this is like it's showing a thunk. I think this is called a thunk. So a thunk is like a part, like a function that not evaluated, not like it's not. It's like it's just showing you the location in the memory, but it's not calling it. But this is practical because you can see what's gonna happen. Code, and then we have 3, 5. But if we put it in parentheses, I think this will gonna force the evaluation, same as if we pass strict when we Nix instantiate. Let's see. Now it evaluated it, but it's still not. Now it did. Wow, that's like the second step of lazy evaluation. How do you force it to show you the code? How do you force it? How do you force it? I don't know. Can I just add strict? Yes, I can add strict. Wow. You see the levels of lazy evaluation? So first, like you have code, like a thunk, and a 3 and a 5. And then you have a thunk. You did the evaluation is done, but it's like, yeah, can you add these numbers? Yeah, I can add these numbers. Well, add these numbers. Okay, I just did. Well, give me the result, you know? So with strict is like you are saying to someone, add these numbers. Says, yeah, I did add this. But give me the result. Well, you didn't say that I give you the result. Well, give me the result. So it's practical. This is really practical. I'm kind of a I like lazy evaluation. It's nice. It's nice also. All right, let x, fx, x, this is lambda, lambda 1, this is what we did. The first example reads apply to a. Second example reads fa, that's what we did. Multiple arguments. Okay, multiple arguments. The time. Wait, I have to check something. So let's continue. Multiple arguments, also known as curried functions. There's a link here to Wikipedia. Currying, yeah, it looks kind of complicated, and it's a really cool thing. Defunctionalization. Yeah, I don't know. Function spaces topology. Yeah. But it's like a function, you know, because we are used to, let's say you add two numbers, and we are used to like have the function has one function. We think like one function takes two parameters, but it's not true. It's like every function takes only one parameter. It's like a function it's like every function has one hand. So, and you need help, right? So if you need to take two parameters, you need another function that's going to take the second thing, and your one hand and takes, it's like your one hand takes the function that has also one hand. Every function has one hand. And then it works kind of like that. So it's like nesting. So example, x and y and x plus y, right? So that's like the add function. The above function is equivalent to x that takes one argument, right, and returns another function, y, that with x set to the value of this. So x plus y, x is, yeah, this is the part when it becomes not clear, even now when I reread it, and I read this many times. But the conceptual idea, I guess it takes time until it, settles down, the meaning, occurring thing. I won't now talk too much about this, but it's like even if you had like x, y, z, c, f, it's like each function takes one parameter, sends it above, and then they do something, then they sense it above. It's almost like the manufacturing factory in old times. Like each person does one thing, and then it sends to another one who does another thing. So it's like one whole thing is made over 100 people who all did one little thing. It's kind of like that. That's actually functional programming works like that, and you combine these little things to make big things. So it's not like you have one person doing lots of things, like with the imperative languages, or like classes or something in, I don't know, Java or C++. I don't know that. And like where you have bigger functions doing all kinds of things. This is like building blocks, like Minecraft or like Lego. Okay, there are much better explanations on this than what I'm saying now. The above function is equivalent to x. Okay, right? This function takes one argument, returns another function, right? Example. F, well, that's just what we said. F, this is the add function in F1. The cool thing is here, I think this is called partial application. So let's go out. Let's go out. Helix partial.next, right? Partial.next. So let's say we're going to do add is x, and then we're going to have a y, and then we're going to do x plus y. So what are we going to do? Look at this. So we're going to do add 5. Now, is this going to work? So this is a partial application. We can actually use this, right? So even though this function add takes x and y, we are already giving it a 5. So we're going to give it, so let's save this. Actually, let's quit, go to Nix REPL. Let's call this my partial is import, and we're going to import the partial.nix. So now we have it. My partial is what? Is a lambda, right? It even shows the file name. Let's do a type. What's the type of my partial? Is a function. It doesn't say that it's a partial, but we see if we call my partial with a 5, what are we going to get? Or let's say 10. What are we going to get? We should get a 15. My partial, oh, we put space here. We should get a 15. We are getting a 15. What if we now even give it, can we give it, let's say 2 and 3? We cannot. Attempt to call something which is not a function but an integer. So my partial takes now one more argument, even though it's defined as taking 2 arguments, right? taking 2 arguments, but we already gave it 1. So that's the, I think this is called partial application. This is done in Haskell. Applying the function. So yeah, if we ask what is this, like near partial, it says it's a lambda, right? That's so even if we add strict, I think it's showing it's a lambda, right? I don't think can we add, probably there's a way to add the number here to apply to something. I don't know. Applying the function which results from f1 to another argument yields the inner body. And then when we give it the second, we get 3. All right, that's kind of clear. Attribute set argument, known as keyword arguments or destructuring. Nix functions can be declared to require an attribute set with specific structure as argument. This is denoted by listing the expected attribute names separated by commas and enclosed in braces. So these are arguments, but this is now an attribute set that has certain arguments, and then you do a certain kind of operation on those arguments. And if we value this, we get a lambda, right? So the argument defines the exact attribute that have to be in that set. Leaving out or passing additional attribute is an error. So what's the example? Let f a b, a plus b in f. So this is like before. So this is like, so let's, wait a second, example, let's do example 3, let's do e3. So let an in, right? Let an in. So we're going to have a set, right? A set, a b, we need this, and we're going to do a plus b. Do we need to put this? Yeah, we need to put this. So, but now we need to write. We can't just, you see, write 1 and 2, or like, yeah, like f1 and 2. You see, it just won't work. We have to write f, and we have to write what's an a. So this is now another attribute set that where we declare our value. So a is going to be 3, and b is going to be 2. So this should work, right? So if we Nix instantiate eval, and we do e3, we're gonna get 5. The command succeeded. All right. What's the counter example? Let f, what does it mean, a counter example? Something wrong? Oh, something wrong, yeah. Wrong. Let f is a plus b in f a1 b2 c3. All right, so this is the same as the first example, but it's like, let's say you want to add like a c is 4. C is 4. So it's interesting, it doesn't show that it's wrong. I have a nil. This is the language kind of a thingy, like, see if I write h here, I'm expecting syntax error, it's showing me there's a mistake. But if I do this, it's not showing me there's a mistake, but there is a mistake because it doesn't have a, what's the word, it doesn't check types or something. Because if I evaluate this, it won't work. It would be nice if I would have like a smaller console. Wait a second. Wait. Oh yeah, I can do like this. Yeah, I've removed the frames. I removed the frames. Yeah. Well, okay, I can do this like at least. Okay, cd dev. Yeah, I should not have removed the frames. Better, you see? This is like you wanna be cool and remove the frames. The appearance. Scrolling. clearance. Yeah, but then I will have frames above too. I like this, but I cannot. You see, yeah, I don't have a tiling manager. I used to have, but now I'm. All right, let's not change the subject. So so if I let's this is so if I do near e3. Oh no, if I do near e3, I'm gonna get a, you see, did you mean A or B? You see this error from call site fa function f called with unexpected arguments. See, it won't work. It won't work, right? It won't work. Error, right? Unexpected argument C. Default values. Default values. Additional attributes. It's. Well, I think it makes more sense maybe to put additional attributes above the default values. Actually, let's write this down. Maybe I'll make a suggestion at Nix.dev. So I have to put this into words somehow. So the counter example, the attribute set argument, the example, attribute set argument, default values, copy link, dismiss, create bookmark. Okay. How do I frame this? I like to use Notion AI to help me with wording. Like, you know, this is how you can you can contribute. This is a great way to contribute. Look, this attribute set argument. What's the point here? The next part of the tutorial goes into default values, and default values are, let's say I want to have here like you see, I have to change everything now. I would rather put default values. So let's say I have an A and I have a B, but I set a default value of 0 to B. And that way I can just call A1. I can just give it an A1, right? And then it will do A plus B, and it's 1. And now example this. But then you kind of lose the context from this before. I'd like to continue. Like, I like to fix the counter example. The counter example should be fixed, right? So the counter example, then comes the default value part, and then the additional attributes. And then the additional attributes part. Now, maybe the additional attributes part would make more sense to be right after the attribute set argument, because it kind of fixes it introduces the ellipsis. It fixes the counter example by introducing the ellipsis. So without losing the, you know, what's the train, without losing the train of thought. I don't know, the train of thought in where you had an extra C is 3. That was an error, right? That was a call that was an unexpected argument. That was an expected argument. Now with now with additional with ellipses, passing an argument. Unlike, you see, it even says, unlike in the previous, it even says, unlike in the previous counterexample, it even says in the additional attributes part, unlike in the previous counterexample, passing an argument that contains additional attributes is not an error. This might be too pedantic, you know, but this is something like, I need to fix this. Ask AI, fix spelling and grammar. Notion is really much better than ChatGPT. ChatGPT is too generative, but Notion can really like nice. Then comes the default value part, followed by the additional attributes part. Perhaps the additional attributes part would make more sense right after the attribute set argument because it effectively addresses the counterexample by introducing the ellipsis. This prevents losing the train of thought where you had an extra C that was an unexpected argument. This prevents losing the train of thought where you had an extra C that was an unexpected argument. Maybe this is this place selection, but this prevents losing the train of thought. Losing the train of thought with, this prevents losing the train of thought. But this prevents, this kind of stays within the same, this kind of stays within the same thinking thought, within the same stream of thought, in the same thought. As stated in additional attributes part, unlike in the previous kind of example, passing an argument that contains additional is not an error. Yeah, I may check this. I may check this. Check with Nix Dev documentation. So you could like open an issue on GitHub. Let's actually, should we do that now? GitHub. No, maybe not. Maybe not. Like, yeah, I already opened this actually. I should follow up on this. I found an error. Nix.dev issues. Missing, stable joy, Jatsu. Common expression patterns. New issue. Site improvement tracking issue. Styling content structure technical infrastructure. Okay, observations. So see, this is how you can add observations. What is you are seeing? What are the systems? What are the symptoms? This is what, okay. What am I seeing? Additional attributes. Default values. Attribute set arguments. It's a counterexample. After the additional attribute set argument part comes the, after the, okay, we could do like, after the, yeah. After the attribute set argument comes the default value part section, followed by the additional attributes part. Perhaps the additional attributes part would make more sense right after the attribute set argument because it effectively addresses the counterexample by introducing the ellipsis. This kind of stays within the same thought. I won't write this. Introducing the ellipsis as stated in the additional attributes part. Unlike in the previous counterexample, passing an argument that contains additional attributes is not an error. Perhaps, or I could just ask for it. Why is default value part between? Why is default value part between? Perhaps the additional attribute part would make more sense right after the attribute set argument because it effectively addresses the counterexample by introducing the ellipsis. Yeah, this might be really too pedantic, but it's not an error. Yeah, maybe I could just, who knows, new issue. What is what you're seeing? Given what you're seeing, what is the problem? How would I name this? What would be a good title for this? I don't know. Ask AI. I don't know if they like what would be a good title for this. To be a good title. Suggestion for reordering sections. Reordering sections. Ah, it's not bad. Suggestion for reordering sections. Question. Yeah. Maybe it does have some kind of a sense. Attribute set argument structuring. All right, let's move on. I'll see about this, but it's kind of like this. You can maybe post it here, or maybe in the Matrix chat room. Let's go to the Matrix chat room. This is exciting. Why not? Let's show this. There is a Matrix Nix documentation. Nix documentation. Nix documentation. I don't know if this is maybe I should make an issue or post here. Let's see. I'm not sure if I should be better. I have a question. So this is the Nix OS documentation matrix channel. So people that lead documentation are here. I have a question about possible reordering of sections. I'm doing the tutorial, the Nix language tutorial, and this part, and it's about this part. It's about this. It's about this. To the attribute set comes default value part set followed by the additional attributes part. Why is default value part between? Perhaps the additional attributes part would make more sense right after the attribute set argument because it effectively addresses the counterexample. As stated in additional attributes part, unlike in the previous counterexample, passing an argument that contains it's not an error. Not sure if I should open an issue and about possible sections. I have a question. Like, why is the default part between? All right, I'll just ask this. Let's see what they write. Exciting. All right, let's return. Example, let FA and F1 A1 we provided a counterexample. Okay, so the default values, also known as default arguments. Destructured arguments can have default values for attributes. This is denoted by separating the attribute name and its default value with a question mark. Attributes in the argument are not required if they have a default value. let f is a, b. Also, this like we provide a kind of, it's like kind of a, this is a, it's like p. It's almost like, yeah, it's, let's say you want to calculate the, all right, can we do like hx circle area dot nix and let n so we're gonna circle area a and b is the default value. So circle area, so let's call it circle area is, we have a set, and inside of set there's an R and there is a P with a default value of 3.1415, right? We do that. And what do we do with a plus b? But it's R times P. R times P, right? Right? And now in what? And A is 1. All right. So what if circle area, and we're gonna give it R is what? R is, let's say, 5. So this should work. R is 5. I'm just trying to pretty print it. Okay, circle area is 5. Oh, I didn't do this. All right, this is cool. So we have circle area, RP, and P has a default value of 3.1415, R plus R times pi, and circle area is R5. What will happen if we Nix instantiate eval circle area dot Nix 78.5375? This is correct. All right, this is a nice example of a default value. Additional attributes. Did someone write here something? No. Additional attributes. It's a default value. Well, maybe not. Additional attributes are allowed with an ellipsis. Additional attributes are allowed with an ellipsis. So now we come back to our old problem. Our old problem was what? X2, E3. Was it E3? Yeah, it was E3. So we had a C, but we didn't work, right? A, B, A plus B. So it will work. It will work if we add an ellipsis. So now it will just ignore the C. It will just ignore the C, right? So let's do NIE E3 and it will output 5. So we see that it added A and B and it ignored C because we put an ellipsis. If we didn't put an ellipsis, then it wouldn't work. Okay. So unlike in previous counterexample, passing an argument that contains additional attributes is not an error. FAB ellipsis A plus B, this is the same example, it's 3. Named attribute set argument, also known as add pattern, add syntax, or add syntax. How else would I read this? Or add syntax. An attribute set argument can be given a name to be accessible as a whole. An attribute set argument can be given a name to be accessible as a whole. This is denoted by prepending or appending the name to the attribute set argument separated by the sign at. Example, AB ellipsis add arcs and then AB plus, and if you want to add something that's not declared here, you can add it here. So that means, oh, okay, this is coming back to this example, right? So even though it shows us it's 5, when 3, it adds 3 and 2, and it doesn't add the 4. It doesn't say that it's an error, but it doesn't do anything with it. So if we want to use the C, and we cannot add it here, undefined name. It says undefined name. But if we write here args, is it args? It's args, yeah. If we write here, it's args, and then we write here args C, now we can access it. And now if we write this, and now if we evaluate it again, it should output 5 plus 4, it should output 9, and it's outputting 9. All right, so this is also kind of clear. It looks a bit, you know, it's not impure. I guess the example is simple because you're declaring something here and you're not sure what you're going to add here, but it is. Yeah, I don't know. The use cases of these are probably useful, but now it's just like more like a language kind of a thing example. Did someone write something in here? No, but a lot of people have seen it. All right. Example argc, that's the same example. Function libraries. In addition to the built-in operators, plus equality, and this is the AND Boolean operator, there are 2 widely used libraries that together can be considered standard for the Nix language. You need to know about both to understand and navigate Nix language code. We recommend to at least skim them. Built-ins, also known as primitive operations or premops. So yeah, you have this packages lib. Wait, let's not go ahead. The built-ins, so they are implemented in C++ as part of the Nix language interpreter. So they're part of the Nix language itself. And you like, if you want to make your own built-ins function, you would have to write it in C++ and upstream it to the Nix language, you know, and they would have to accept it and accept it in the Nix language interpreter. So the built-ins is like a core functionality, primitive operations. But they're primitive also, all built-in functions, and shows how to use them. So I guess these are just, you know, primitive operations. These functions are available under the built-ins constant. Example, built-ins toString. Yeah, Haskell has stuff like this. And some of these things you import, like some of these things like GHC has it, and some not. This is not a Haskell tutorial. Built-ins toString, premop. Import. Most built-in functions, yeah, built-ins toString is like, you know, like Nix REPL, built-ins. That's probably already here, right? Built-in. Can I do like built-ins? No, I didn't spell it right. Built-ins. So it's showing us. Look at this. It's showing all of the built-ins. Element, add, false, fetch, get, fetchers, current system, current time. Let's do current time. And this is probably stardate 171472. This is the Unix time. Built-ins toString. Built-ins to JSON. Built-ins to JSON. You do like built-ins to JSON. And let's do A1 and Bs2. And it's showing us built-ins to JSON, but it's not prettified. Built-ins true. Try val. Okay. Zip address with built-ins map. Is there a map? Fold. There's a fold. Is there a map? There's a map. Built-in map. Map is cool. Right, we like maps. Import. Most built-in functions are only accessible through built-ins. Most built-in functions are only accessible through built-ins. A notable exception is import. Did someone write here something? Oh yeah. Sure, it doesn't sound wrong. I don't have a strong preference here. Feel free to make a suggestion that reads somehow fluently. I don't have a strong preference here. Feel free to make a suggestion that reads somehow fluently. Yeah, okay. All right. Nice. You see, these are like little things you can start working. And NixOS, I love NixOS, and the community is so great. And it's wonderful if you can engage with them because you get motivation and inspiration. Because these are really great Nixers, and they love NixOS. So it really helps to get engaged with the manuals, and then to read, and then to go online, go to GitHub, go to Matrix channel, go to Discourse, go like read and get engaged, and it will help the learning. It helps the learning. And if you're too much, I'm just talking from my experience. I was like a lot of years just alone with my little reading, and then you get somehow it's just you go not bad. I guess you have to grow up in a way. I guess I grew up a bit. Import. Most built-in functions are only accessible. Doesn't sound wrong. I don't have a strong preference. I feel free to make a suggestion that reads somehow fluently. Yeah, not sure what do I do now. Should I say yes? Oh, yeah. I guess I'll see about this after the stream. Maybe in Finicil we'll write something. Maybe in Finicil was most built-in. All right, import takes a path. Okay, we did import. I think echo 1+2 outputs the file, and you import it. You import it in a REPL, and you get detailed explanation. It evaluates it, the Nix expression. Right, that's clear. Like the shell command writes the content of 1+2 into the file. We did before this with the partial. We wrote the partial. When we went to the REPL, we imported the partial application. There was like 5, and we applied it. We called it with the number 10, and we had a 15, right? It's typing something else, right? Handwerk. Handwerk. I like this, German. I like that people sometimes try to have a more common nickname, and it's like you just have a nickname that you have. I remember, yeah, and I remember. Okay, I won't start with I remember. Since a Nix file can contain any Nix expression, imported functions can be applied to arguments immediately. That is, whenever you find additional tokens after a call to import, the values it returns should be a function, and anything that follows are arguments to that function. Okay, let's just see import. Yes, that's what we just said. Imported functions can be applied to arguments immediately, what we did with the partial application. Okay, detailed explanation. Okay, I won't read this. I've been talking a lot this morning. The preceding shell command reads the file and evaluates it. Yes, it's an error if the file system path does not exist. Reading the file equivalent to the file contents. Yes, parentheses are required. Separate function declaration for application packages.lib. So the Nix packages repository contains an attribute set called lib. So this is the set which provides a large number of useful functions, like the built-ins, but they are implemented in the Nix language as opposed to built-ins, which are part of the language itself, which is written in C++. So you can write your own libraries and import them in upstream them or import them into packages.lib, but you would write them using the Nix language. The Nix packages manual lists all Nix packages library functions. Like if you go like libassert, what's the libassert? Libassert, libasserts. Located, where is it located? So here you can see where is it located. Asserts Nix. Oh, and then you can read the definition. A rec. Throw if predicate is false, else return pred. So this is a great way. You should it's great to start reading code. Example, assert message, false nope. There's example, assert message, predicate built-ins, throw. So it's using the built-ins throw in constructing this. Assert one-off, name val x lib element. This is using another lib function, lib generators to pretty, right? Specialized, assert echo which name. So yeah, I mean, I hope like someday, maybe I'm gonna be, maybe it would be nice to like work on some libraries. Like you can work on packages, but you can also like develop, well, I guess it all develops from itself. Once you have experience with packages, you run into problems here or that, you want to abstract over things, you start to develop libraries. That's, I guess, for me, that sounds like really the next level. The first level, like, is learning, and the second level is like you package stuff and you kind of move around and everything. But once you start really abstract things and even upstream them, that's like a different level. Oh, I see now. It's like describing two directions. The assignment is describing direction from value to variable, and the binding from identifier to value. That's helpful insight. I choose assign because it's not just programmer jargon, but also makes sense in everyday life. You assign someone to a task like that. You wouldn't bind a task. This is interesting. Yeah, but you assign someone a task. Yeah, you can really, you wouldn't bind a task to some, like, yeah, we were talking the other day because the Nix language, the Nix REPL, like, wait a second, like, there's this bind expression to a variable or a sign. What do you say, like a sign or a bind? No. Anyway, it's just interesting. Let's do packages.lib. How long is this going on? 1 hour and 19. Let's make it until the end. Come on. Packages.lib. So that's the packages.lib, right? So the Nix packages repository contains an attribute set.lib. Okay, yeah, that's what we just said. These functions are accessed through packages.lib. As the Nix packages attribute set is given the name packages by convention. So let packages is you import the Nix packages with an empty set. Oh, yeah. That's why it didn't work before. Like if you just write import Nix packages and an empty set, it would try to import the entire Nix packages with 100,000 packages. So let packages import the entire Nix packages in what? Packages lib to string to upper. Use this one and turn all these to upper letters, right? So if we say Nix REPL, let's make it smaller. So let packages is import Nix packages, right? And packages dot lib dot strings dot to upper. Notice that these are subsets of this, right? To upper, what? Well, I want to say hello world to upper. So you see, it took some time. And now it took, did it take from the local Nix packages from my NixOS configuration? Probably. And now we have hello world. All right. So detailed explanation. This is a more complex example. Now it really explains what's happening. So what's happening? Yeah. The file path is determined by the value of the lookup path. That's the lookup path we did before, which in turn is determined by the Nix path environment variable at the time of this Nix expression is evaluated. So this is kind of impure a bit because it depends on the time when the Nix expression is evaluated. From the Nix for brevity, this has to do with flakes. Like you could pin a fully reproducible example would therefore look like this, like Nix packages, because it's not clear from this what a version of Nix packages are we importing. So let Nix packages is what? Fetch tarball. This specific archive, right? NixOS, Nix package, so it's this specific revision of Nix packages and import that. And then always pin your sources. Always pin your sources, right? That's kind of nice. Oh, student can say. Is there some more discussion? You could bind a task to someone. You could bind a task to someone. No, but you would bind. But they sometimes they're like a bind. That's hence I guess hence the identifier. Because to identify someone doing a bunch of tasks. Yeah. Bind a task to some. Yes, but you bind a name. I thought the thing means you bind a name to someone you assigned a task. I thought it's like you bind a name. Binding from identifier to value. I can is it I don't want you wouldn't bind a task to someone. Would you bind a name to someone whom you assigned a task? Would you bind a name? You bind it, but you bind a name to someone whom you assigned a task. But you bind a name or you bind a task to someone. Yeah, this is okay. What will you often see is that packages is passed as an argument to a function. By convention, one can assume that it refers to the Nix packages attribute set, which has a lib attribute. Packages, no. Okay, this is lambda. This is like what we did before, but it's just showing some stuff we can do. I won't type all this now. Nix instantiate eval file.nix import packages true Scotsman. So then it lost the, You'll see in the NixOS configurations that lib is passed directly. Yeah, we have the lib in some of, like, I guess in Home Manager or in NixOS configuration. Example, lib let to be true, in lib trivial or to be. I didn't get this the first time I was reading. This is too much now. To make this function produce a result, you write it to a file. Although this is kind of cute. And Nix instantiate import Nix packages.lib true. Wow. Sometimes both packages and libs are passed as arguments. All right, let's skip this. Built-ins impurities. So far, we have only covered what we call pure expressions. So we declared data and then transformed it with functions. We have to think you bind an identifier. You bind a name to someone who you assigned it, to whom you assigned it. I thought you assign a task and you bind a name. Bind a task. In practice, describing derivations requires observing the outside world. Yeah, now we're gonna stop being a baby and we're gonna go out. There is only one impurity in the Nix language that is relevant here, reading files. The file system as build inputs. Ah, what did I do? Okay. The only way to specify build inputs with file system paths, dedicated functions. Yeah, and I just lookup paths, built-in current system paths. Whenever a file system path is used in string interpolation, the contents of that file are copied to a special location in the file system. The Nix store is a side effect. So if when we do echo 123 data, expression data, so that goes into the Nix store. Yeah, I don't understand this. So is this supposed to be Nix REPL? Yeah, I don't know. So like, if I do 1, 2, 3, right? 1, 2, 3 in data, and oops, 1, 2, 3 in data, and now I go in a Nix REPL, and what? I can just do data, unexpected dollar curly. Okay, let's try with this. Oh wow, that's cool. Nix store data. I can't believe that's in Nix store. It's kind of mind-blowing, this. The preceding shell command, writes the characters 1, 2, 3 to the file data. That's clear. But the Nix expression refers to this file as data and converts the file system path to an interpolated string. All right. Such interpolated expressions must evaluate to something that can be represented as a character string. A file system path is such a value, and it's so that's, I guess that's how it maybe that's how the paths are like saved as these hashes. Hash name Nix store path. The Nix store path is obtained by taking the hash of the file's contents and combining it with the file name. File is copied into the Nix store as a side effect. So a lot of these things will just vaporize, for me at least. But it's good to read them after a while and then do stuff, and then it just sticks a little bit more and more. Fetchers. Okay, for me, actually, this is the most simple thing, like conceptually. It's just files to be used as build inputs to do not have to come from file system. That's like you need to build your program, your package. You need something from the outside world. Let's say you want to get your source from GitHub, so you do built-ins fetch URL, built-ins fetch git, built-ins fetch closer. There are a lot of differences within them, and you can get really deep. But so far, built-ins fetch URL, and it's some can unpack archives. Derivations. Derivations are at the core of both Nix and the Nix language. The Nix language is used to describe derivations. Nix runs derivations to produce build results. Build results can in turn be used as inputs for other derivations. The Nix language primitive to declare a derivation is the built-in impure function derivation. All right, we're going to do this in packaging tutorial. It's kind of more like reading at the end of the tutorial. Package using MK derivation. So the evaluation result of derivation is an attribute set with a certain structure. Okay, so it's like MK derivation produces an attribute set with a certain structure and a special property. It can be used in string interpolation and in values to Nix store path. So import packages.nix, right. Right, detailed explanation, right. Worked examples, right. So far, we have seen artificial examples, illustrating the various constructs. You should now be able to read Nix language code for simple packages and configurations and come up with similar explanations of the following practical examples. The goal of the following is not to understand what the code means, but how it's structured. All right. So we get now the structure. We import let in the message is hello world in what? In shell. With build inputs with packages say the program, shell hook say. So this whole thing is basically me doing say hello world. That's it. But this you can save as a file and send it to someone. And if that someone does not have a say, the shell will, like in a special in shell environment, will import the Nix packages, and of course they have to have Nix installed. Yeah, they can be just on Windows or Ubuntu. We'll import Nix packages, and the message hello world, it's gonna put it inside of say the message string interpolation. A lot of things we covered are here. So this is going to be used with building packages. This is an explanation. I won't read this. NixOS configuration. Yeah, we have this in configuration. It's kind of, the more you do it, the more the Nix files look more clear, and it's like they speak to you. Package, though this is a simple package. Lib standards. No, it's growing. We have a p name and a version. So we have string interpolation. So instead of writing hello 3 times, we write pname. Instead of writing hello, we write pname. No, this is really practical because let's say the version number changes or something. So you can just, you change it in only here. You don't have to change it in 3 places. Returns. This thing. Okay, and then the references. Next steps. Packaging, and you can remove unused build results from the Nix store with Nix collect garbage. Do we have something? Yeah, we have this result we did. And 10 megabytes were free. All right. Learn more if you work through the examples. Reveals Nix language reveals the structure of the code, but does not necessarily tell what the code actually means. It's kind of cool. Because that's the functional beauty. Like the structure itself can be applied to many meanings. And usually, like everyone has a meaning. But a lot of the meanings have the same structure. So by giving it the same structure, you can even encapsulate the meanings you are not prepared for or you have not thought of, but the structure helps. Example. These are kind of cool things. Well, I won't read this now. The Nix pills. Nix pills. I'll probably do a series with Nix pills. Yeah, this is a nice part where there are all these questions that you could have just by looking at this code. Like that x will be a function that given an argument returns a function. Does x return a function? What's the data type of the end result? You don't know. Like this is which data type is y and ZA will be like which data type like you know that Z will be an attribute set at all. Will Z be an attribute set? I don't know. Nix bill, yeah. Overrides, overlays, Nix modules. That's it. Okay. Next, packaging existing software with Nix. And that's going to be another tutorial. So now I'm going to finish hour and 37. All right. It was great. Thanks for watching.